Hello everyone, this is Bhumi Shah, Assistant Professor, LJ Institute of Pharmacy, Pharmaceutical Chemistry Department. I welcome you all to e-lecture series of Pharma Ignite. Today we will discuss in detail about complexometric titration. In our previous lecture, we have discussion over chelates, chelating agent, sequesters, sequestering agent, varieties of ligand and all. Now today we will discuss in detail about their uh, ligand, EDTA or varieties of titrant, indicator and all. Now up till now we know that a complexometric titration is a technique of volumetric analysis in which a soluble, undissociated stoichiometric complex is formed. Means a complex formed is soluble and which is not, or that means it is a stable one. It is not dissociated easily during the addition of titrant. In a complexometric titration, the formation of a colored complex is used to indicate the end point of the titration. Complexometric titrations are particularly useful for the determination of a mixture of different metal ions in a solution. And here indicator used is capable of producing an definite color change is usually used to detect the end point of the titration. Uh, which complexation reaction can be used as a volumetric techniques? So the reaction which reaches the equilibrium rapidly after each portion of titrant is added, that can be analyzed by this volumetric technique. The reaction in which interfering situations do not arise. For example, the formation of several different complexes of the metal ion with the titrant during the titration process. So that type of mixture cannot be analyzed by this technique. That means you have to or you can analyze the reaction which is having very less interfering situation. The reaction in which an indicator is capable of locating equivalence point with fair accuracy is available. Ultimately, complexation titrations are particularly useful for the determination of a large numbers of metal ions in solution. In practice, the use of EDTA as a titrant is well established in such complexation reaction. So let us have in detail about EDTA. This is the structure of EDTA. EDTA means ethylene diamine tetraacetic acid. Here you can see it has 4 carboxylic acid functional group with 2 amino groups. But due to this carboxyl group, they have very less solubility in water, and that's why we are using their disodium salt as a titrant. EDTA is a polydentate ligand as it donates its 6 lone pair of electrons for the formation of coordinated covalent bonds with the metal cation, and that's why it can form metal EDTA complex easily. Now let's discuss stability of metal ligand complex. There are so many factors which influence this stability of complex. First, nature of metal ion. A small ion with a high charges, they leads to stronger complex. Then nature of ligand. The ligands forming chelates that imparts extra stability. How? For example, the complex of nickel metal with a multidentate ligand that is more stable than a unidentate ligand. For example, ammonia. Then third, basicity of ligand. The greater the basicity of the ligand, that results in greater stability of the complex. The next is size and the numbers of chelate ring. The formation of 5 or 6 member ring that provides the maximum stability. Here you can see a different size. The bigger size or bigger ring, that is more stable. The numbers of metal chelate rings. The stability of the complex is directly related to the numbers of chelate rings formed between the ligand and the metal ions. Greater the numbers of such rings, greater is the stability. Then last is steric effect. The steric effect can also play as an important role in the stability of the complexes. More steric hindrance, less is the stability. Next, a role of pH in EDTA titration. Basically, EDTA titrations are carried out in a buffer solution. Use of proper buffer is important because that affects the stability complex of metal and ligand complex. For example, we need alkaline pH for the metals which is having very low stability constant, while we need low alkaline to mild acidic pH for the metal which is having high stability constant. So it is very important to maintain the pH during EDTA titrations. The next is indicator of this titration, that is called as metallochromic indicator. These are the organic compounds which have capability to form color complex with EDTA. Now we have two varieties of complex. One is metal complex form with indicator, then metal complex form with EDTA. Initially in a conical flask we have metal indicator complex, and once EDTA has been added as a titrant, this metal indicator complex break down and that metal combines with titrant EDTA and forms a new complex. And so here a condition is these two complex have different color. During the course of titration, the metal ion from metal indicator complex is replaced to form metal EDTA complex. So here in the theory of metal ion indicators, you can see the reaction correspond to the use of metal ion indicator in EDTA titration can be represented as initially we have metal ion and indicator complex that combines or reacts with EDTA and form metal EDTA complex and free indicator. This reaction will take place only if the metal EDTA complex is more stable than metal indicator complex. The indicator color change also affected by the hydrogen ion concentration. So it is convenient to define the conditional indicator constant K, in which varies with the pH. These are the list of different indicator which we can use in a complexometric titration with their structures. This is all about today's lecture. That this includes where we can perform complexometric volumetric analysis, what is the stability of metal ligand complex, factors affecting that stability, regarding indicator used in a complexometric titration. Now in our next lecture, we will discuss varieties of complexometric titration. Hope you enjoy this lecture. If you have any doubt, you can comment below the lecture, and you can find more lectures through our YouTube channel Pharma Ignite. Please like, share and subscribe our YouTube channel Pharma Ignite. Thank you.